Hi everyone, in today's lecture we will see the drawbacks of our routing information protocol. Hi everyone, my name is Bhavishya and let's begin today's lecture. So the parameters that on which we'll see the limitations of our RIP protocol is the very first is our hop count limitation. So when we talk about our RIP protocol, the metric that we use is our hop count, how far it is. So we identified it by hop count. So now the maximum hop count that we can have in a larger network or in a network is just 15 hop counts. The moment we reach 16 is when it will declare it as unreachable. So we can't use, in this case we can't use RIP in a wider or a larger network. So RIP disqualifies. The second one is the metric problem. The only metric that we have in our RIP protocol is our hop count. It doesn't give value to our load, it doesn't give value to our latency, it doesn't give value to our bandwidth. For example, in this situation we are using RIP where, let's suppose, we have a slower link but it has a hop count of 1. Okay. At the other hand, we have a high speedy link but it has a hop count of 2. So in this situation it will prioritize the link 1 with hop count 1, which is not effective and efficient. So this is how RIP disqualify. The third one is slow convergence. Let's suppose we have a larger network, but here the problem with RIP is it takes a lot of time, a lot of time to make other routers understand that, bro, that router was dead. Believe me, it was dead. So how it happens? Because why it is slow? The reason why RIP is slow is because it takes 30 seconds to update, to talk to other routers. So the updation time for RIP is just 30 seconds. Let's take an example to understand it in a very good way. Let's suppose we have a topology where we have let's suppose router A connected to router B and then router B connected to our server, right? Now let's suppose the link between router B and server got disconnected. Okay, so server is down right now. Before our router B can tell to our router A that the pathway to our server is dead, the updation time got purged or expired. And in this case, our router 1 sends in its regular update table to our router B saying that I know the information of our server, the path that we can follow, and it is just 2 hop count far from me. Now in this case, our router B get a little confused and it updates it in his own table to the direction of our router A. Now our router A knows that it is in the direction of router B, and our router B, as it got confused, it knows that the direction towards our server is towards router A, and this is how it gets a loop, and they will increment in every 30 seconds. They will increment their hop count. It's a loop, right? But it will go up to our 15 hop counts. Okay, so this is how it has a low convergence, which conclude that RIP failed. After that, the last one is it takes a lot of our CPU resources as well as our bandwidth, because when we talk about RIP broadcast, our RIP version 1, and when we talk about our multicast, that is our RIP version 2, it sends their entire routing table in a network. And let's suppose we have a larger network. There, sending the entire routing table takes a significant amount of our resources, our CPU resources as well as bandwidth. So all of these parameters that we have discussed concludes that RIP is inefficient for our larger networks. Also, as we have saw in our previous lab, the topology was our switch 1 connected to router 1. Router 1 is connected to our router 2. After that, our router 2 is connected to our router 3, and then router 3 is connected to our switch 2, right? Now in this topology, as you can see, no further routers are connected to our switch 1 and switch 2. So to save our bandwidth, we will passive our switch 1 and switch 2. After making it passive, the router will go silent, but the traffic happening or the communication happening between switch 1 and our switch 1 and router will be the same. So to do that, we will go to the router configuration mode in our CLI on our GNS3. We will type the command passive, after that dash interface, and then we will type the interface, let's suppose fast ethernet 0/0, and this is how it will happen. To check if it's working or not, we will see in our show running configuration. Then there we can see that switch 1 and switch 2 gets passive. So this was it for this lecture. I hope you enjoyed. See you in the next one.